Hi there, this lesson is on the mole and mass. So we've already talked about the mole and representative particles. Mole and mass is going to be very similar, except you're going to have to find the molecular mass of the compound that you're dealing with prior to setting up your conversion factor. So finding molecular mass, anytime you see a gram unit, that's going to be your clue. You're going to have to find the mass of the compound. For each atom, you're going to multiply the mass of the element, which is going to be found on the periodic table, by the subscript, and then add all of those masses together. So for example, if I have H2O, we have hydrogen, which weighs 1 AMU, and in our compound we have 2 of them. We're going to multiply that by 2. That gives us 2. And oxygen weighs 16, and we only have 1 of them, 1 oxygen, so that is 16. 16 plus 2 is 18. So that is our molecular mass for water. So you are going to need to use your periodic table for these to find your masses of each atom. So to go from grams to moles, remember, want over have. So if we have grams and we want moles, we're going to put moles in our numerator. 1 mole is going to equal the molecular mass of a compound. So you're going to start with whatever you've been given here in the problem. You're going to multiply it by 1 mole over the molecular mass of the compound. That is going to allow your gram units to cancel out so that you're left with a mole, which is what you're trying to find. Now, if we go the opposite direction from moles to grams, now we want grams. So we're going to put grams in the numerator. So we're starting with however many moles that you have been given. We have moles down in our denominator so that the mole units can cancel out. Grams is left in the numerator, which is what we are looking for. So let's look at a couple of examples of mole mass conversions. First one is how many moles are in 4.8 grams of copper to chloride. Well, the first thing you have to do is find the mass of copper to chloride. So if you look at the periodic table, copper has a mass of 64, and we have 1 of those. And chlorine is 35, and we have 2 of those. So 64 plus 35 times 2 gives us a mass of 134. So our copper to chloride equals 134 grams. So now we can set up our conversion factor. We're starting with 4.8 grams of CuCl2. We want moles. So we're going to put moles in our numerator. 1 mole. 1 mole is always equal to the molecular mass of a compound. And we just found our molecular mass to be 134 grams. So we're going to put that in the denominator, 134 grams of CuCl2. So now when you do the math, your grams units will cancel. You are left with the mole, which is what you are looking for. So 4.8 divided by 134. Correct number of 6 figs in this case is going to be 2. So we get 0.036 mole. Make sure you're watching your rounding. Make sure you're paying attention to your sig figs. Remember, zeros in front are not significant digits. So that's why we have the 0.036. Go ahead and try this one on your own, and we will discuss it tomorrow. This is a hydrate. It looks weird the way it's typed. It's supposed to be MgSO4 7H2O all together. So remember, when you're doing a hydrate, you're going to find the mass of the whole entire thing. So you're going to take the mass of the magnesium plus the mass of the sulfur plus your 4 oxygen plus your 7 times the mass of your water. So just keep that in mind when you're setting this up.